So we're starting off the video very quickly with a mention of tonight's homework change, which is for section 9.6a, ratios and roots. We're doing 1 through 9 odds, and now we're also doing 13 through 49 odds. That's the big change. Tomorrow, it becomes a smaller assignment, 51 to 67 odds. All right, we good? Good. Backing up to the warm-up. When you have to reduce or cancel factorials, start with the bigger factorial and work it down until you get to the smaller factorial. So 2k factorial actually equals 2k times 2k minus 1 times 2k minus 2 factorial. So you break the bigger one down until you reach the smaller one, and that way you can cancel. And then you're left with 1 over 2k times 2k minus 1. Is that okay? To break down exponents, remember 6 to the n plus 2 is the same thing as 6 to the n times 6 squared, right? And then 3 to the n minus 1 is 3 to the n times 3 to the negative first. So if you write all of them with powers of n, then your 6 to the n over 2 to the n, 3 to the n all cancels, and you're just left with 36 over a third, which is 108. All right, good. I promised David I would call this the detour method. So because when I was first doing these, like 6 to the n plus 2, I was writing 6 times 6 times 6 to the n. And he was when I said, why don't you just write 6 squared 6 to the n so that kids can see like how it breaks up. I said, you know what, that's nice. Let's do that. Right? So that works well. Yeah.
I like the organ better.
Good. Any questions on those?
No, ma'am.
Because we're going to use that a lot today. All right. So today we're learning the ratio and root tests. The ratio test, we will use the ratio test probably more in the next 4 sections than all other tests. Yeah. So it's a good thing it's a fairly easy test. All right, so we're going to use ratio test to determine convergence, root test to determine convergence, and I already showed you your homework change. Are we ready?
Yes, ma'am.
Begin. Okay, write down the ratio test. The ratio test, it looks complicated, it's really not. It just says that if the limit as n approaches infinity of the absolute value of the n plus 1th term divided by the nth term, basically you take like the next term in your sequence rule or your series rule and divide it by the current term. Anyway, if that limit is less than 1, it converges. If it's greater than 1, it diverges. And if it equals 1, it's inconclusive. This test works great for factorials, but it's not just limited to factorials. It works great for nth powers. It works great for alternating series. It works great for all kinds of functions. As a matter of fact, you will get so used to using this test that this will often become your go-to test.
How is the second different from the first? Because infinity is still like greater than 1.
Yeah, I know. This is because technically infinity isn't a number; it's a constant.
Today I will take that.
Oh, 102,000.
You should like it's 9
Yeah, I know, but it's not right.
Oh, what's her name?
Because it's 3 times 3.001592652.
Exactly.
So
it's off by
Well, she's there,
you said it's 3.14 minus 4.14.
Oh, Reagan's wife?
Let's see, what is
I
that?
still remember her, I will always remember her as guest starring on Good Times.
You know how to use
There was a show, it was called Different Strokes. She guest starred on it one time. Oh, yeah.
Did you hear Bernie's?
We don't need to talk about it now. Almost went there, but that's good. There's nothing wrong with it.
Yeah, it's
Okay.
9.00477796.
Alright, so, for example,
So Bernie said,
it was because of that I knew the Speaker of the House was Tip O'Neill. It's because she talked about it on the show.
Is it like opera? I mean, not opera.
It was a sitcom. It was a family sitcom.
What was?
It was a family sitcom.
well, basically is a family.
Yeah.
Vote for me in the north.
Okay, alright, here we go. So we're gonna start with an example. This is the sum. This is the sum as n goes from 1 to infinity of 2 to the n over n factorial. If the terms are always positive, you don't have to have the absolute value because they're always positive. So you will see in the examples that I don't have an absolute value. That is not because you don't need it for all of these problems. It is only because when the terms are always positive, it is moot. Right? Okay. So here we go. We start by finding the nth plus 1 term. So all you do is replace your n's with an n plus 1. And you divide it by the nth term. One of the things I have found is that my students are lazy limit writers. And I've mentioned this before, I'm going to emphasize it today. Because many times during class today, I was called over by students to say, I got this, is this right? And what they got was this simplified, and they hadn't taken the limit. Because you forget you're taking a limit when you don't have LIM in front of it, right? So if you just get in the habit of writing your limit statement with every step, you won't forget you're taking the limit, right? So, because you gotta take the limit. The limit's important. Alright, so now, I've always called it keep, change, flip, but I learned today that it's, oh my.
Flip the second and multiply.
You skipped
Yeah,
the first
what-
part
what-
of this.
Oh,
Okay, can you say the whole thing?
Fractions.
Flip the second, multiply. Okay, dividing fractions, flip the second, multiply. Okay, so there you go. So we're gonna divide the fractions, right? So when we rewrite this, we can cancel. And remember, when you're canceling with powers, as long as the bases are the same, you can just subtract the exponents, right? So 2 to the n plus 1 over 2 to the n is just 2 to the first, right? Right. Yeah.
Absolutely.
Okay. N factorial over n plus 1 factorial. Which one should we change?
Bottom.
The n plus 1 factorial, right? So n plus 1 factorial becomes n plus 1, oh, I gotta recenter, times n factorial. And then you can cancel the n factorials. So what you're left with is 2 over n plus 1. If all you had was 2 over n plus 1, you would look at it and be like, I don't know, right? But we're taking the limits as n approaches infinity. So the limit as n approaches infinity of 2 over n plus 1 is just 0. Now, if the limit is 0, what do we know about the series? Converges.
Absolutely.
Yes, and we don't have to worry about that whole absolute thing for this, just converges. It converges because the limit is less than 1, yes. Alright. So, are you ready to try a couple?
Yes.
Alright, close your eyes for a second because I think yep, there we go. Alright, you can open them.
You wanna close your eyes?
Yes.
I didn't
Do we
think it
only
is.
need to worry about absolute and conditional convergence when it's alternating series?
Yeah.
Oh wait, you have to do.
Why were you whispering?
Alright, so let's try these. Set them up. Simplify it, let's see how we do.
Do you need to change it into another form, or can you just leave it like that? I think you
I
do.
think I'm gonna walk around and point anyone's paper who is missing limit statements along the way.
I'm good. I understood. See, I already wrote down my answer. I knew it was a limit though. See.
Yeah, but what you had written was a lie to say that this equals that.
But it does, Rich, because you see it was inferred. I used invisible
It's
ink.
inferred.
Oh, good one, Dylan.
Shut up, Shreyas.
Watch our tone, please. I missed what was said, but,
He said something.
okay, that's
Limits,
okay.
and he said, shut up.
Now it sounds like my voice. All right, we don't need
Yeah,
to do he
yeah,
says.
basically.
All right.
Your 7-year-old.
Let's just treat each other with respect
At
and
least I don't forget my
kindness.
limit
Okay, it's done, it's done. It's done, let it go.
No.
Okay.
Never, don't forgive, never
All right.
Yeah, so we
Very
can
nice
trick each
limit
other
statements.
using the correct grammar.
All right, he's good, very good. I'm pointing, but that's because it's good.
Thank you.
Yes, yes.
I'm glad you did point
Yes.
that.
Can you make me
Good,
feel?
very nice.
I wish I would use this close.
Yeah. You need it for Esther stuff to go on? Oh, wait, no,
Oh,
you
I'm
know.
not there yet. Now I'm there. This is so comfortable. Like, try this. Try it.
I would never say that's two to the end. I don't know if it's almost true. I kind of like it.
Okay, okay.
I tried.
That is good.
And I was like, oh.
So that is
Good.
2 times n plus 1.
Oh, I see. Yeah, let's see.
I'm working on it. This is the whole.
Or you could think of it since it's the same degree top and bottom, it's just the quotient and the coefficient. But either way.
Yeah, I got converged.
Beautiful. Very nice.
Yeah, tell me. Alien, what
Oh,
time?
I'm trying to make it.
So it's.
You can't say that.
Tammy's such a legend.
I think
Oh, you know what, you have a plus and it's times.
Lay hospital.
You have,
The whole problem is times,
I know,
yeah.
hospital.
That makes it
You don't need to
much
use
harder what you've got, yeah.
Yeah, I was looking at
yeah.
Wait. Miss Price?
That.
second one's
Miss Price.
Good, good limits. Alright, here we go.
It would be two
I added my.
It doesn't converge at that, so does it?
I don't think
I
so.
don't think it does.
No, it doesn't.
Oh, you're on the next one. Okay.
Yeah, I added my boss upstairs.
Your bus.
My boss.
Oh, it was good.
Wait.
That's cool guy.
Your nice little voice.
Yeah. No camera, he doesn't. He's a cool guy. Steve Sigmund is probably my favorite
Very
sponsor
close.
you're talking about. Pretty chill guy.
As a matter of fact, get there as far as I think anyone got today.
Oh, Miss Price.
Most people took a guess.
Is the answer of the limit the point at which it converges?
No.
Okay.
No, that's a good question. Yes or no?
Did I get it?
The first one, yes, you did. Very good. Try the second one. Yeah, when you get a limit value, is the limit equal to the sum of the series?
No, man.
No. No. It's just determining convergence.
Then why do we do that?
To determine convergence.
Well, why do we need to determine convergence?
For the sake of determining convergence.
No. So you can give it not divergent.
Did you have a question?
Oh, no. Yeah, well, the n plus 1 makes a difference. I don't think so.
Oh, this is surprising.
That's a very knowing.
Oh, I think it's what's.
Wait, first, did you have the
I got input.
Oh, yeah, I was gonna ask you.
Well, what'd you get?
Actually, no.
Love the second one. Second one. I'm getting into
Even though America's
My work is much.
It's not English.
It's
There's
just
a
the
definite
American people. Look at example 3.
No, it's just what it's saying.
It's not infinity,
Nobody cares.
but it does diverge.
So m plus 1 over is.
I have bigger.
No.
So far, not a single student has gotten
Okay.
number 3.
We both got it.
Number 2.
What? No,
number
I
two.
just-
The third example, the second problem. You got it?
I got diverges.
It does diverge.
Yeah, because when you do the thing, then you get n plus 1 to the nth over n to the nth, and then so the top
What
of
does
those
that
can be bigger.
approach?
What does that approach?
It approaches a specific number.
Probably infinity.
No, no.
Alright, let's walk through.
Do we need to find out what it approaches?
You do,
Oh.
because it's something you're gonna have to recognize.
Oh,
So-
it is E.
Oh, very
That was
good.
Liam. Gotta give credit to
That's
Liam.
okay, alright, well done. Okay,
Okay.
so, for the first one, we replace all of our n's with n plus 1s, right? And then divide with the regular series rule. Okay, keep change flip. So we multiply by the denominator, do some fancy canceling, lots of canceling. I enjoy canceling, there is something satisfying about canceling. So, yeah, so we do lots of canceling, we end up with 2 times n plus 1 squared over 3n squared. If you recognize that it's the same degree, top and bottom, then your limit is the quotient of the leading coefficients, if that rings a bell. If you don't recognize that, feel free to L'Hopital, right? So I have L'Hopital up here just in case you did that, that's fine. So either way, you should get 2/3, which is less than 1.
Is it that?
And therefore,
What is
the series converges. We are good mathematicians. So, the next one, n to the n over n factorial. So, we replace all of our n's with n plus 1s. So we've got this. So, change flip. You can cancel the factorials, right? This becomes n plus 1 times n factorial, so I cancel the n factorials. So, bam, n factorials are gone.
You take the 1 over.
Then what I saw was, hey, we have an n plus 1 and an n plus 1. I could write this as n plus 1 times n plus 1 to the nth, right? And then cancel the n plus 1s. And then I have 2 matching exponents. So, we end up with that. From there, we might have gotten a little stuck, right? Yes, Shreyas?
So you can do the whole thing to the end like we usually do with geometric
You
series.
can.
And then if you divide it out, it's 1 plus 1 over n to the n, and the limit of that.
Alright, so, if you rewrite this as the limit of 1 plus 1 over n to the nth,
Some good stuff right there.
so it is good stuff.
Wait, I know that.
Expand
Something
pages.
like
Missing, but anyway, if you rewrite it as 1 plus 1 over n to the nth, I'm hoping that you recognize that this limit, we try to emphasize you need to learn it. If you haven't learned it yet, try to learn it. It equals e, right? Which is greater than 1, so it diverges, yes.
So on a test, would we have to say that equals E, or can we just stick with the n plus 1 to the n over n to the nth and say, hey, it diverges because the top will always be bigger?
Like, I get it.
Or you could just do that.
Saying that the top will always be bigger is kind of like saying it approaches infinity.
But if you're saying the top will always be bigger, then what you're really saying is it's going to be greater than 1 as an approach to infinity. Because if the top's bigger than the bottom, it's greater than 1. If the bottom is bigger
I
than
guess
the
I
top.
can see that.
Okay.
Yeah, that's a logical argument.
Okay.
Yeah. Yes.
Why does 1 plus 1 over n to the n equal e?
If you remember, I'm not going to work the whole thing right now, but if you remember from last chapter, what we did was we had to set it equal to something like y and then take the log of both sides, right? Put the n out front and then do a whole bunch of finagling with a L'Hopital, right? Yeah, that's how you get the e. Yes. And by the way, and then a couple, like maybe a week or a few days ago or something, we realized that it's always e to whatever is up here, e to that exponent, right? If there's an x there, it's e to the x. If there is a 2 there, it's e squared. If it's minus, like 1 minus 1 over n, it's e to that negative exponent, right? So, good to know. All right, root test. Okay. Yeah, there's not much to it. Don't worry, you're gonna get tons of practice. Yeah, I know you're worried. Yeah, I was.
Are you
Root test is quick.
Oh, this is the root test.
Root test is quick, but it doesn't get used very much. But it is quick. All right, the root test is quick.
The integral test.
So the root test is a quick test, but it only is really useful in very specific types of problems. Those types of problems are problems where everything is to the nth power. The reason that it works well when everything is to the nth power is because the root test requires that you take the nth root. And that way, when you take the nth root of the nth power, the powers cancel. So here's what the root test says. It's similar to the ratio test. It says when you take the limit as n approaches infinity of the nth root of the absolute value of a sub n, if you get an answer that's less than 1, it converges. If you get an answer that's greater than 1, it diverges. And if you get an answer that equals 1, it is inconclusive. So I wrote a little note here that this works great with nth powers. Root test does not come up that often.
Is it on our test?
I honestly couldn't tell you which tests are on your tests, but there's a lot of them.
Will this be on the AP test?
That's something I would even be less knowledgeable about than your test.
You have to, but almost.
I actually, what's funny, of all the problems I've found so far dealing with series convergence on the AP exam, I haven't found any yet that you would be able to do, with the exception of that one cute little geometric series problem that we did a week ago. That's about it. So, once we get into sections 9, 7, and higher, that's when we're going to hit AP problems. Yes?
It makes sense on this test, but why are we always using the absolutes? Okay, yeah, then. You know.
Well, for that, if you're not using the absolute value, then
You can't have a negative root.
Well, no, I said that's why I make sense of this test, but why?
From the previous test, we also
Ah.
have the absolute value.
Because if you think about, you know what kind of made me think of it, if you think about the whole geometric series test, right? If you think of a geometric series. So if you take a number where the absolute value is less than 1, doesn't matter if it's positive or negative, if you raise it to infinitely high powers, right? That number is going to approach 0 over time. Whether it's positive or negative is irrelevant. It's the absolute value of that number being less than 1 that's significant. So it wouldn't matter if you think of the geometric, if our r was positive 2/3 or negative 2/3, the fact that it's less than 1 is going to force it to go towards 0, right? I think that's why we're doing absolute value, is because the sign is irrelevant. And here, we're doing absolute value because you have to have it positive under the root to work, right? So I think that's why, as a matter of fact, to me, this test is almost an umbrella of the geometric series test, right? Because if you think of your geometric series, right, if we have a sum, wow, I really do need to do this. I know, I have to write way below where it's going. Okay. Well, that's a man. I gotta fix the word, I'll fix it. I'm capable of writing the letter N, it's just not working.
I don't know.
It's like switching between like normal.
There we go. That's as good as it's gonna get.
Calibrated. Calibrated?
Calibrate.
Yes, can you calibrate it?
There,
Good
okay.
one.
Anyway, if you guys remember for geometric series, the whole point was that the absolute value of r has to be less than 1, right? if we plug this into the nth root test, what do you get? You get the nth root of r to the n, which is absolute value of r, which is less than 1. Right? Because remember, this a can just go in front of the sum. The coefficient is irrelevant. So, to me, this is almost like an umbrella over the geometric series test. Because that kind of gets, I don't know, it falls into this. But this actually covers more types. So, anyway, I don't know if that answered your question. That's the best I got right now. All right, moving on. Ah, don't look.
We already did this one.
Okay, we haven't. These are new. These are root tests.
Oh.
Yeah. Okay, so it's time for you to try some root tests.
How do I do root?
Take the end.
Oh, wait. You gotta go back.
Same problems. Yes, because it's off. It's not. No, it's exactly. Because it's off. You're clicking. Look.
Whoa, what happened?
Okay,
Oh,
it's not
It's
aligned.
off. I clicked the wrong button. That's it.
Yeah.
Sorry,
So
video.
one-
We're aligning the board.
Well, she said.
What video?
Those
I thought the camera was there just as like
Just take the
spot.
end through. And it's great.
It's great.
Okay,
The
there we
limit
go.
root of a of n.
Come on.
No, buddy.
Why do I have all these Okay. All
Oh,
right.
look, the answer.
Here we go. So, first example. So, we have the sum of e to the 2n over n to the n. If we had to write this as one whole thing to the nth power, could we do it?
Yeah.
Yes.
we can.
You don't have to do the root test, but it just makes your life a tiny bit easier if you do. Yes?
Can we have coefficients?
Yeah. Coefficients don't matter. Matter of fact, if there's a coefficient, you just put it in front of the sum.
Yeah, but that's not the question. The question is whether or not.
All right. So what we do then, if we're going to apply the root test, is we take the limit as n approaches infinity of the nth root of our series. So we take the nth root of our series. What is the nth root of e to the 2n?
E
squared.
It's e squared. You remember when you take a root, you're dividing the exponent. So anyway, the nth root of n to the n is n, right? So we end up with the limit as n approaches infinity of e squared over n. E squared is a constant, right? So you have a constant over infinity, which is going to 0. So this is going to converge by the root test. If you want, if it bothers you to do it this way and you want to write it as e squared over n, now it's going down. To the n. Anyway, if you want to write it like that first before you take the nth root, right, if that makes it easier, that's fine, right? Whatever works better.
If the board keeps not working, we should just quit math for the rest of the day.
I think we should just burn the smart board.
See, now I've got all these blank pages in here.
You're adding blank
You're adding
pages
more.
by clicking.
Tap the
there.
left arrow.
Because it's
Yes,
going
tap
down.
the left arrow. See, look.
Yeah, there you go.
All right, so give this a try. Some nth roots. Write those limits.
The second one could be first one's comparative growth rate.
Low of the bowel.
It's like they're
Not an active.
No, I meant to throw it to
Dude, first you break my pencil.
Oh,
then
he
you-
broke his own pencil.
No,
in front of
straight
my
up break
eyes.
it. Where's the proof?
The burden of proof is on you.
There is no
Innocent
proof.
until proven guilty.
There is no proof. Yeah, but that means I'm also innocent because neither of us broke it. So nobody broke anything, yet the evidence is somebody broke it. And there's no evidence that you didn't do it, therefore you did.
That's not how it
It's
works.
Schrodinger's cat.
The absence of evidence is not the evidence of absence.
It is, we are running an opposite judicial system to the
Yeah.
US.
Guilty till
Alright, so the first one,
So that means that you're guilty until proven innocent as well.
when
Both of us are guilty or both of us are
When you
innocent.
take the nth root, you end up with the limit of 4n plus 3 over 2n minus 1. And if you want to think L'Hopital, that's fine. You get 4 over 2, which is 2. 2 is greater than 1.
2 equals.
Wow. So therefore it diverges.
Yeah.
Get traced.
So are we always gonna get problems like this easy where it's just to the end basically?
You're going to get a whole variety of problems, and you're going to just be told, hey, or asked, does it converge, does it diverge? When you're talking about your test. When you're talking about your homework tonight, the ratio and root problems are set up very nicely for the test to work well.
Alright.
Okay, so for the next one, you have ln n over n to the nth. We apply the root test, and we end up with ln n over n. This, if you do comparative growth rates, right, then this is slower over faster, or you could do L'Hopital, which gives you 1 over n over 1, which is just growth. Hey, so this guy converges. Questions?
No ma'am.
Good. So, okay, so ratio test and root test are very similar in what respect?
They involve n.
They both have, what
Less than
statements have to
1.
be in front?
Greater than one is.
Limits. They are both limits as n approaches infinity. They both have the same results, right?
Yeah.
Greater than 1 diverge, less than 1 converge, equal 1 inconclusive, right? Good. Okay, so what we're going to do now is work on your quiz. I am not going to save this.
Is this the 9-1?
No, we're doing math off, we're doing the 9-1 quiz. Okay.